Good morning, everybody, and welcome to the third webinar of LIFE ITS4ZEB Talks series. Today, we present a life cycle assessment and its implementation in the project. My name is Nicola Moro, and I am the project manager for Studio Fieschi and Soci in LIFE ITS4ZEB. Studio Fieschi and Soci is an Italian consultancy company focused in sustainability measuring and also reporting. We have two offices. The headquarters is in Turin, and we have a second office in Venice. Studio Fieschi and Soci is part of Tinexta Group. We have more than 20 years of activity across all economic sectors all over the world, and working with every kind of company, large, medium, small enterprises, and so on. There are more than 25 members in the team with different backgrounds, such as environmental scientists, engineers, or economists, biologists, and so on. During these 20 years, we developed a strong expertise in life cycle assessment application, and we are now one of the most renowned companies in this specific topic in Europe, and we got several direct assignments by European Commission on life cycle assessment, in particular within the PEF, Product Environmental Footprint Program of the Commission. And our role in ITS4ZEB is related to this expertise. We have to evaluate the environmental and also the economic impacts of the new system developed in the project by other partners with the application of a life cycle assessment methodology. And we have also to provide the environmental KPI requested by the LIFE project about the impacts of the project itself. So let's start talking about what is life cycle assessment. Life cycle assessment is a methodology based on the concept of life cycle thinking that is defined by the Life Cycle Initiative as a way of thinking of the consequences of the environmental, economic, and social effects of a product throughout its entire life. This means that we have to consider the entire life cycle, starting from the extraction of the raw materials to their processing in the production of components, in production of products, and so on. Then the distribution of the products, their use, and finally the end of their life with the disposal of the materials they are composed of. So we can say that life cycle assessment is a methodology to measure and so to quantify impacts in the life cycle. Why we should do a life cycle assessment study? Here I can show three main reasons. The first one is to have a full picture of the environmental, but also the economic and social impacts of a product, of a service, of a process, and so on. And this picture is comprehensive in two ways. The first one is, again, the fact that it considers all the life cycle of the product, so without the possibility to shift burdens from one phase to another. And the second way is related to the fact that typically in an LCA study we consider several indicators, environmental indicators in particular, in order to have a picture considering all the environmental aspects. even if, as you probably know, one of the most known application of life cycle assessment is carbon footprint, which is a life cycle assessment study focused in just one indicator that's related to the global warming. The second reason to perform a life cycle assessment study is the possibility to identify in the whole life cycle which are the elements that can affect more in the final performance of the product or process. And so to understand which could be the processes or the materials that have the greater impact. They are called hotspots. In order to come into the third reason, in order to evaluate how we could act to reduce these impacts, working in particular on these hotspots. There is one more application that it's important to talk about quickly. It's related to the communication. In fact, life cycle assessment can give reliable information to be communicated to customers, but in general to all the stakeholders of the company. One example is the EPD, the Environmental Product Declaration, that is an environmental label based on a life cycle study. So, how we should perform a life cycle assessment study? There are two international standards, the ISO 14040 and 14044. That describe the way that we have to do a life cycle assessment study, defining four main phases. The first one is called the goal and scope definition, when the main methodological aspects of the study have to be defined, such as which are the goal, so the objectives of the study, which is the object of the study, of the analysis, and which are the system boundaries, and so on. So some methodological aspects. The second phase is called inventory analysis. And in this phase, each life cycle stage is analyzed, identifying the input and output streams, and also quantifying each stream in order to have all the data, all the information, quantified information to make the third step, which is the impact assessment, where all the collected data are elaborated in order to give the results expressed in the indicators we need. The fourth phase is across the other, and is the interpretation. The goal of this phase is to be sure that all the phases of the study are in coherence with the goal, the objective of the study itself. Just as information, in ITS4ZEB, at this moment we have completed the inventory analysis, and we are starting the impact assessment. So let's go to how we are implementing life cycle assessment in ITS4ZEB, starting from the goals of the study. The first one is to evaluate the environmental and economic performance of the ITS4ZEB system during its life cycle. So to have the full picture, I said before, of the system from an environmental and economic point of view. So we will perform a life cycle assessment and life cycle costing analysis. The second goal is to compare this system with other technological solution that can give the same function, in order to understand how the system developed in the project performs in comparison with other solutions. And third goal of the study is again to understand which are the hotspots related to the main impacts of the product of the system during the life cycle. These are the goals. The system boundaries are based on a cradle-to-grave approach, so a full comprehensive approach in the analysis of the life cycle stages, from the raw material acquisition to the production of components, the production of the final system, its distribution, so the transportation to the installation site, its installation, the use and maintenance stage, and finally the end of life, so the commissioning of the system, and then its recycle or disposal. For each stage, we consider the input in terms of materials, water, energy, and also the outputs such as waste or emission in air or in water. There are other three key aspects, methodological aspects in the study that I want to show you in this slide. The first is the scope of the study. It means what is the product system we have to analyze, which is the object of the study. The second is the function of this system. And finally, the first is the functional unit. So it means what is the unit we could refer the impacts to, so that we can really compare different systems. So the scope is of course the full ITS4ZEB system, and also the alternative system that fulfill the same function. For example, a system with a natural gas boiler and a cooling system, or a system with a central heat pump with or without an electric battery storage. And in all this scenario, we will consider also a photovoltaic system in order to have a common basis for the comparison. The function of this system is to meet the heating, cooling, and domestic hot water demand of a residential application, optimizing the self-consumption of the energy, and in general optimizing the system performances. In order to do this, we choose as functional unit the provision of 1 kilowatt per hour of energy for heating, cooling, and domestic hot water production in this residential system. So this is the main aspects of this study. As I said to you before, we are now collecting all the data, and we are starting the model, the SEA model in the software. But today I want also to show you some preliminary, let's say, observations. So what could we expect from this study? To do this, I can start from the results of a LCA study we performed in a previous LIFE project coordinated by Innova, which was related to the production of an air conditioner using propane instead of traditional refrigerant, so a low GWP gas as a refrigerant gas. The first observation is that in that project, we saw that the main impacts occur during the downstream phase, in particular the use phase, and was related to the energy consumption. It's quite typical for electric products. But this give us two points of interest for the new study, so the analysis of ITS4ZEB system. And these points, in my opinion, are related to the contribution of photovoltaic systems in the total impacts. And so to see how self-production of energy and also the storage of the energy, electrical or thermal energy, could affect this distribution of the impacts during the life cycle. Even if we expect that most impacts will, however, occur during the use phase, I think that another point of interest of this study will be the comparison between the materials used for the different solutions, and in particular related to the storage, electric storage or thermal storage. I think that this could be a very interesting point to see. The second slide and the second observation is related to the contribution of different energy mixes. We saw how energy consumption is the main contributor for the calculation of impacts, and we tried to see how these impacts change with different energy mixes, considering the application of the product in different countries. Here we can see the differences between the application in Italy, France, Belgium, Germany, Great Britain, and global average. And we can see that all impacts has great difference between the countries related to the different mixes that are present in these countries. And all the impacts except abiotic depletion, because it's related more to the extraction of raw materials and so to the production of the systems. Here the point of interest is again to see if the self-production can change this difference, making them more equal, let's say. This I think could be another point of interest of our analysis. Last observation is related to the use of propane instead of other traditional refrigerant gas. In the previous project, we tried to analyze different scenarios, in particular two scenarios where in the first, no leakage of refrigerant gas occurs during the life cycle of the machine, and a second scenario, here it's called baseline, where a leakage of a total quantity of refrigerant gas is foreseen. And we see how the impacts change between these two scenarios, considering a machine with propane and a machine with a traditional gas. And we see that when the machine with propane doesn't change in terms of impacts in the two scenarios, there is a significant difference if the machine uses the traditional gas in these two scenarios. It's about 7% more the impact of the scenarios with a total leakage using this gas. And I think that this is again an interesting point of interest also in this new project. So we are now at the end of this webinar. For the information about the final results of our study, can give you an appointment to one of the last episode of this series. But please go to follow us in this series of webinar, Life It's4ZEB Talks, and stay tuned also on our social media and follow us and especially follow It's4ZEB. Thank you very much for your attention. If there is any question, you can write them in the comments. Thank you very much and see you.